Hey everybody, welcome back to another episode of our MLOps community meetups. Today we had a little bit of a snafu, or should I say I had a bit of a snafu with my internet while we were recording this live, and for some reason the recordings that I had are only audio. So sadly, you're not going to be able to see any of the video recordings, and this to me is a big bummer because Kai had some great slides that he was sharing with us. If you'd like to see those slides, you can go down into the links that are provided below and you can check them all out. I made sure to get them all from him so that you can see them. Again, sorry about this. Looks like technology just does that sometimes, and I think you all understand. So without further ado, let's take it to the meetup. Kai, welcome, man. Thank you for being here. Let's talk about you for just a moment. You are an evangelist at Confluent. We all know that Confluent is the muscle behind Apache Kafka. You speak all over the place, and most recently, you've been really doing a lot of blogging, at least how I got the attention of you, or no, how you got my attention is by doing some prolific blogging on this whole idea of machine learning and Kafka and how these two are like a match made in heaven. So I think that's really what we want to dive into today. But more specifically, you have this really cool blog post about the tiered storage that I wanted to go into. So I'm going to just let you introduce yourself a bit on what you've been up to and how you got into tech. And that right there is how far I got until my daughter decided to unplug the Wi-Fi router at home. So we jump back in after Kai has explained a little bit about himself.
And with this replication, you can also get high availability, even if nodes go down or network goes down. And so with this, Dimitrios, while you're joining again, I'm just explaining what Kafka is so that everybody has the same understanding.
Thanks, man.
Maybe let me finish that now. And so with this characteristic now, Kafka also is good for the storage part. And with this, you really decouple the producers and consumers from each other. If one producer produces data continuously, he doesn't ask if the consumers can consume it or if they are falling behind or if they're offline. And this is where Kafka is also the storage and back pressure system. And per Kafka topic, so per different, like a queue in a messaging system, you can define a retention time. And therefore you can say, okay, for these logs, I only want to store them for 2 hours. But for my customer transactions, you can also store them for a year or for 10 years. And with this in mind, then you can also reprocess data later. And this is the key interesting characteristics. And so this is the high level overview about Kafka for the people who don't know it. And so in addition to that, then, Kafka is messaging and storage in the middle at scale, highly available. But also it provides tools for data integration with Kafka Connect, both to legacy systems like a database or like a mainframe, and also to modern technologies like HDFS or S3 or MongoDB or MQTT. And you also have streaming capabilities, which means you can also process the data with tools like Kafka Streams or KSQLDB. And this was now the overview which I want to give, that you have the high level understanding. And now, Dimitrios, I can hand over back to you.
So one of the perks of working at home is that I got my little daughter running around and she unplugs the internet occasionally.
Wow.
So that's why I took a momentary break, and everything that you just said is not going to be in the recording, but that's all right. Everyone who is here right now was privy with that information. So I don't know what exactly you got into there, but I know that you've written a blog post about how Kafka is and can be used as its own database these days. Can you go into that a little more? And I know you've talked about how it's like ACID compliant, and there's some really cool stuff that's happening as Kafka just matures and it becomes this beast that is super interesting to think about the use cases for. So can you go into that a little more before we get into
Yes.
this tiered storage?
Absolutely, and that's really important to understand. So Kafka, as I said, is not just a messaging system for sending data from A to B, but it also has a storage component, which means you can store data in Kafka. And the great difference to some other system is that this storage is event-based, like you can see very well in this picture here also. And therefore, you can then also consume data from this log in the same guaranteed order with timestamps. And you can also query, for example, only the data from July 2019, and consume all the events from that month only for some further analytics, like training a model, for example. And so it always depends on how you define a database and what your use cases are. So first of all, you can store data in Kafka long-term and also without data loss and high availability and all these things. Having said that, Kafka will not replace Oracle and Elasticsearch and MongoDB. All have their specific use cases. So you should always think about what do you want to do and what problem do you want to solve. In some cases, Kafka is good enough even for that, because you can query the data in Kafka, but there is no native SQL query which you can do, right? So Kafka does not support ANSI SQL out of the box. There is, again, another tool on top of that from another vendor which you could buy. But the main point is Kafka stores the events and you can query them in some simple ways. And if that's good enough, then you often don't need another database. In other use cases, often people use Kafka as the central event-based nervous system, like in this picture, but then they build a materialized view on top of that with another database, like a MongoDB or like an S3 or like a time series database. And each of these databases then consumes from Kafka the data it needs and stores it themselves for their own analytics. And this is in the end, the relation between Kafka and also other databases.
Okay, so this is a bit out of left field, and I promise everyone that's listening, we're going to get into this whole idea of tiered storage and machine learning. But yesterday I was talking to this guy, Alex Milowski from Redis, and we were riffing on the idea of when you're doing machine learning and you just are researching and you're taking in all this data, you're doing whatever you want with this data. He was saying it would be great, or he would love to know if there is something of like a database that you only need for X amount of time, and then you can just let it blow up. And I was making the analogy of like Mission Impossible, when you listen to the recording, and then it goes, "This message will self-destruct." And so I was wondering if you have ever thought about that and if that, like, it kind of seems like Kafka could do something like that.
Kafka actually is part of that. So the main idea here is very interesting because, as you can see in this picture here, on the right side, you ingest all the data, and one of the consumers is the data warehouse, right? This is where you want to store the data forever in tables, and then you do aggregations and reports for the BI user. That's something where it's persistent also forever. However, having said that, in addition to all these other applications, some of them real-time, some of them are batch, we also see more and more data scientists using Kafka, because if you store the events in Kafka, and this is exactly what you just described, then you spin up a new Jupyter notebook and you write some Python code and consume just the events you're interested in. Like we have use cases, for example, for regulatory reasons where they have to prove that some business transaction happened in a specific month. Or if fraud happened for a specific user, then they only have to consume the data for the partition where this user is in. And so the data scientist just consumes from Kafka this data, and then they do their analytics with that, which can be either machine learning or just business rules or Tableau or whatever. And then after that information is done, they either create a report or they store the information somewhere else, but then they shut it down again. And this is exactly one of these scenarios. So maybe to go back to another picture to show this even more, this is the idea behind that. The producers, which is in this case, for example, the orders or the payments, they are appended to this log. And in this log, they are unchangeable, right? So they are just appended. So that's a great thing. Nobody can change them afterwards. But also they are in here in guaranteed ordering with timestamps. And therefore, if you have a specific customer who does transactions over the last 10 years, then you can be sure they're here in the guaranteed ordering like they happen with the timestamps. And then the data scientist can take them. And while in this example, consumer 2 might be a real-time application for fraud detection in real time. But now the data scientist comes in and he says, I'm the consumer 3 here, and this is the Python app, and I directly want to consume the data from Kafka with my Python client. And I analyze it, and then I shut it down, and that's how it definitely works.
Awesome. So let's talk for a minute about why you feel like, I mean, you've touched on event streaming, right? And what it is. And why do you feel the adoption has been so high with Kafka? And I know there are other tools. Like I was talking to a friend the other day and he was saying, you know, RabbitMQ could be used, or PubSub
Yep.
and Kinesis, these kind of tools. But it seems like Kafka is just a beast. And so what do you think the reason is for such high adoption?
That's pretty straightforward, and that's, however, a very common question. So many people again say that Kafka is a messaging system, and that's completely wrong, because that's just a part of Kafka, and therefore it has very different feature set than something like RabbitMQ or other messaging systems. And actually, we have plenty of customers which started trying to solve a problem with messaging, but then they found out they need much more than that. And I can give you a specific example, and it's easier for you to follow. And maybe I even can put up a slide, because then it's easier to follow that use case. But I want to talk about Deutsche Bahn, which is the German railway. So therefore, this slide is also in German, but that doesn't matter. This is a customer slide.
I'm practicing my German these days, you know.
Yeah. But the example here, this is really perfect for this question, because Deutsche Bahn had a problem. So this is really about customer experience. In Germany, there's a lot of trains called ICE, and they have the long distance trains, right? And when you're waiting for a train and take a look at your mobile app, it says this train is on time. However, the display, the blue display on the train station, it already says 10 minutes late, 20 minutes late, 30 minutes late. The train is canceled. Please take the next train. And while this happens, you still have the information on your mobile app that the train is on time, even though it's late. And in addition to all this, if you ask the worker on the train station, he already knew 2 hours ago that the train was canceled because there was a defect already in another city. And this is reality today in Germany, right? And this is a huge pain, because people accept that the train is canceled because there is technical defects. But if they can tell you that it's canceled, then you can at least drink a coffee and you don't have to wait at the train station for it, right? And so the funny thing now is what Deutsche Bahn tried in the beginning. They started this project several years ago by using RabbitMQ. Because think about this. They thought about this like, well, we only need information in real time, so let's use a real-time messaging system. So they started with RabbitMQ in the middle. But then they quickly found out, well, it's not just about sending data in real time, because yes, as you can see here in this architecture, some systems are real time. But unfortunately, Deutsche Bahn has a lot of legacy systems. So, for example, these blue displays on the train station, this is a Windows installation. So this only has a file connectivity. And you can only update the file in this display every 10 minutes. And this is a CSV file. So they found out, well, it's not all real time. We can only update it every 10 minutes. So we need to cache the information somewhere, because the real-time information is coming real time. We need to cache it until my file is updated in 10 minutes again. So they added a storage and caching layer to the messaging system. Then they found out, well, the CSV file, it also needs to be processed somehow to correlate with the messaging system. So they added a processing engine to that. And then they found out some of our systems are using other legacy, like an Oracle database. We need an integration framework to add that. And with this, they found out we need 4 or 5 different frameworks to solve this problem. It's not just real-time messaging. And with that in mind, they then had 5 systems. And then they also found out this is hard to operate and maintain. And we already in trouble of scaling all of that for deploying it all over Germany. And so they re-engineered this and implemented what you see here with Kafka, because Kafka provides all of this in one single component. Because again, Kafka is messaging, it's storage, it's data integration, and it's data processing, all of that in one framework at scale in real time. And this is now a great example. And Deutsche Bahn has this live on the first train stations in Germany. And they are now rolling this out all over Germany in the next 1.5 years. And I think this explains on a great use case how there is a difference between just using messaging or using Kafka.
It is funny to me because we always think that the German trains are never late. So you're using
that's wrong.
It's the stereotype of the German trains being on time all the time.
The funny thing here, just to mention it as a side note, is because I'm also often in Switzerland, and in Switzerland, actually, the trains are never late, but they use a simple trick. In every train station, they plan to wait for 5 minutes, right? So they're always on time, of course. They have some back pressure handling automatically. In Germany, the train network is so complex that it's not possible to do that. And that's the reason why you have delays.
Oh, interesting. Yeah. So I'm going to put in the chat right now the article that you wrote that we were kind of basing this chat off of. And one of the things that you speak about in this article is like the old way versus the new way. Can you go into that a little bit more?
Let me just check. I also need, what was it about the old and the new way?
So you were talking about how Kafka used to be and how you used to do things like with the ingestion layer and the data lake, and then the new way that you're doing things.
Yeah. Okay. So I got it. Let's talk about that. So, and I will also use another picture for that. Let me just, I'm sorry that
I like it. You came prepared. You got all kinds of presentations ready.
You know, for the listeners, I think it's always easier if you also have a little bit of a picture where I can explain it, because it's not a podcast, right? So this feels easier for you. So, in the end, what we typically do is we do something like this. That's what people know. So they use Kafka as ingestion layer. That's actually how Kafka was used 5 years ago everywhere, when these data lake companies like Cloudera and Hortonworks and MapR came into the companies. Then Kafka was used everywhere as ingestion layer. You ingested it into Hadoop, and then you build your analytics batch platform on top of that. This has completely shifted in the meantime. You ingest it into the cloud, into S3 objects or something like that. But the idea is the same. So this is how people used to use Kafka, just as ingestion layer into a data lake, and then you store it there at rest and do your analytics on top of that. However, what's happening now is that people understand that for more and more use cases, this architecture is too late, and they wonder why not process the data while it's happening in the stream. And therefore, what we see more and more, and here's a great example for doing that with machine learning, is that instead of first ingesting all the events into a data lake, now you can also consume directly from Kafka. And we have built an example, and we will talk about that later, I think, where we are directly consuming from a machine learning framework like TensorFlow, and we are consuming these events, right? So in this case now, the architecture is simplified because we are using Kafka not just as ingestion into a data lake, but as we just discussed, and you can store the data here also longer with tiered storage, which I will explain in a minute when we talk about it. But the main idea is you have the events in Kafka, and you can consume it directly from machine learning frameworks to also train your models then there. And this is the significant architecture change, which simplifies many architectures, because you don't have two big data clusters anymore with Kafka and with Hadoop, for example, but you only have Kafka's big data cluster. And then based on that, you can spin up your Jupyter notebook and consume the events as we discussed before.
All right, so let's talk about this tiered storage. Can you go into that a bit more?
Absolutely. So if you don't know Kafka in detail, so this is how Kafka normally works, right? So in Kafka, you have brokers. Kafka is always a distributed system, so that it's highly available and highly scalable. And each Kafka broker, which is in the end under the hood just a Java instance, a Java process, but that is used for two things, for processing and for storage. So there's the broker for both. The processing is the compaction, the quota enforcement, the authorization, and all these things. So it's the compute, and it's also the storage. And the storage in Kafka normally is the attached disks. So in Kafka, because you often process high volumes of data, one Kafka broker, which is a GVM running in a Docker container or in a EC2 instance or bare metal, this is attached to often 6 or 8 disks or something like that to store terabytes of data there. And this is the normal approach, like 99% of people do it today. And this actually works great for many use cases because for many use cases, you have this retention time, and after 2 hours or 2 days, the data is deleted from Kafka again. So it's good, right? The data is flowing continuously, but it's not growing. And having said that, as we explained before, more and more use cases store data long-term in Kafka. And then you get into trouble here, especially for big data sets, because Kafka then is getting very expensive. Typically, people here use HDDs, which are not too expensive, but for terabytes of data, this gets expensive. And this is not just about the cost of money, but also about scalability, because Kafka is highly available and it continues working even if brokers crash. But if, for example, a broker crashes, the hardware is down, you need to replace it. And when you replace it, no matter if it's in the cloud or if it's on premise, you need to synchronize the data again. If a disk crashes and you need to synchronize data for terabytes of data, that can take minutes or even hours. And so it's not ideal to have very big data sets in Kafka. And this is now what's completely changed with tiered storage. With tiered storage, in the end, most of the data is offloaded to a remote storage, to an object store. And in this picture on the right, you see how that works. You still have the brokers of Kafka with the local storage, and the local storage is still the HDDs. Or you can use SDDs because you don't store that much storage anymore there. And most of the data is offloaded to a remote store where you can store it on the one side long-term, much cheaper, and much bigger data sets. So we have now customers which really store petabytes of data in Kafka via the tiered storage. And here you see better how this looks like. So you have the applications on top. And the great news is for the application, nothing changes. The Kafka API is exactly the same like before, no single code change. However, under the hood, most of the data is not stored on the local brokers anymore, but on the remote storage. And per Kafka topic, you can decide how long you want to store the data locally, like for an hour or for a day. And afterwards, you offload it to the object store, which can be something like an S3 on AWS or Google Cloud Storage on GCP. And this is really a real game changer because you can store data long-term in Kafka. And it's very cost efficient. And with this now, you can really consider and ask yourself, do I really need another data lake for my new project? Or can I just use Kafka? Because with this, the data scientist can now say, hey, I need all this old data from even if it's July 2015, and you can consume these events. And before we go on with other questions, I also want to point out today, while we are speaking, tiered storage is already available from Confluent as part of the Confluent package. It's not available today open source, but this is also going to change in the next months. So
nice.
together with Uber, and who has the lead on that, and with some other companies, tiered storage, the API will be part of Apache Kafka. So it's expected for Apache Kafka 3.0 in January 2021. And with that, then the tiered storage part will be part of Apache Kafka, and then there will be different implementations under the hood. And Confluent, for example, we have, we spend a lot of investment into that, and this will be an implementation which will support interfaces like S3 on the cloud or GCP or Azure Blob Storage. But we will also certify this, for example, for on-premise solutions like Pure Storage or MinIO, for example. Mm-hmm. And having said that, Uber, for example, has implemented already an interface for HDFS. And so this is then, we will see where the market goes. But the tiered storage API will be part of Apache Kafka, and then there will be different open and commercial implementations of the tiered storage.
And so you mentioned before, I see there's a question in the chat. I'm going to get to that in a second. But you mentioned before the idea of storing these large petabytes of data on Kafka wasn't so feasible before because maybe if something blew up, it would take hours or potentially days to reattach or get up and running again. Does that no longer happen with this, or is it just a nice little hack?
That's exactly the difference, because in Kafka, you need to do so-called rebalancing. So when something has to be moved from one broker to another, or you install a new additional broker, you want to scale it up or down, then you have to move partitions. That's a concept which is very similar also to other NoSQL databases, right? And the big game changer here is that this only happens for the local hot set in the brokers. And as 99% probably are then offloaded to the object store, this there's no impact on that. And that's the big difference. So no matter if you have a gigabyte or a terabyte or a petabyte in the object store, the rebalancing only has to happen for the local hot set. And therefore, this is then done in seconds.
So the question in the chat is about Apache Flink and how this is different than Flink.
I mean, Flink in the end, from a Kafka perspective, is just a consumer, right? So this is just an application on the top. And with Flink, most of the Flink deployments, it's a stream processing technology like Kafka Streams or KSQLDB or Spark Streaming. And in the end, it's a consumer of the Kafka streams. And so from this perspective, it doesn't change anything for Flink. Of course, you can also do, if you're talking about state management in the Flink application, then that's a completely different story. That's more comparable like how you keep state in a Kafka Streams application, because that's then in the client side where you keep state in a streaming application. But that's completely separated from the tiered storage. So even if you use Flink as an application, you can also use it the same way with tiered storage and consume all data from the Kafka interface. Because again, the Kafka consumer interface, and that's the same one which is used by Flink connectors, that's not changing at all.
So you mentioned in the blog this use case of, I think it was a driverless vehicle, right? Mm-hmm. And did you want to get into that or did you have a different use case for it?
No, sure. I'm absolutely happy. I mean, the great thing is that from an architecture perspective, it looks very similar no matter what the use case is. We have actually built an example also on GitHub where we implemented exactly what I'm describing now in the next 2 minutes or so. So we intentionally used the example of connected cars here, because this by nature is, the requirement is that this has to scale. We have to connect to hundreds of thousands of cars. We have to process high volumes of data, and we have to do that in real time 24/7. This is, by the way, an example similar to this is what we have implemented already with some customers like Audi for their connected car platform.
Oh, nice.
But here, in this idea now, you see that, let's start on the bottom left. We have the cars, right? They produce data continuously, for example, with MQTT interface. And then they ingest this into Kafka. And then we get it into Kafka. And from there, we process the data, like at the top with KSQLDB. This, by the way, could also be now Flink or Kafka Streams or anything else. And here you do your ETL, your processing, your filtering, your aggregations, or you build your business applications. And in our case now, one of these consumers is also the green TensorFlow application. In our example, how we implemented this, we have built everything with Docker containers on Kubernetes. And so one of the containers is a very simple Python application, which only uses 2 APIs under the hood, or 2 libraries. One is the Kafka library for Python, so that we can consume the data from the Kafka cluster. And the second one is the TensorFlow Python API or library. And with these 2 libraries together, we have built a scalable real-time application which can consume the data from the Kafka cluster and then train the analytic model with TensorFlow. I want to point out that the model training in most cases is still batch, because that's how machine learning works today. But if you use an online model training model, like for example, online clustering, you can even do that in real time. But the point here is, in this example, we consume the data in real time. And then when we have consumed enough data, then we start our model training, which then can take, I mean, this is still a little bit hello world. This takes a few minutes, but it could also take longer. And then we train our analytic model here. And there is then again tens of different architectures how you would implement that. In our case, the trained model is deployed into I think we used Google Cloud Storage. So we used an object store in the cloud. So automatically the trained model is deployed into an object store. And then on the right side, you see completely separated from that our application where we want to use this model for predictions. And this application is in our case a Java Kafka Streams application, or it could also be a Python application. And this application, when you start that in a new Docker container, or in more Docker containers if you need to scale it up and have it highly available, this under the hood uses Kafka API, so it's highly available, it guarantees the ordering and no data loss and so on. But it also loads this model trained on the left side in the beginning when you start up the application, and then it uses this model under the hood. And the great thing about this example is that here also we do all this model scoring in real time at scale, because it's natively done in the Kafka application. Many people are surprised when they see this architecture, because typically, if you come more from the data science world, you typically use a model server for that. This is something like TF Serving, for example, or Seldon, or something of the cloud service providers. The big problem with them, not for every use case, but if you have a use case like a connected car infrastructure, where you connect to hundreds of thousands of cars, and where you want to do real-time scoring, like for predictive maintenance or for cross-selling and after sales, then it's not a good idea to use an HTTP interface for doing this prediction for every single sensor event, right? And therefore, it's much more robust and scalable if you embed the model directly into the Kafka application. And this is what we did here. And so in this case here, you see different components, all decoupled from each other. On the left side, the cars. At the bottom, at the top, some stream processing and some model training. On the top right, the real-time scoring, which is again completely separated. And in addition to all this, which happens then in real time at scale, we also ingest the data via Kafka Connect into, for example, MongoDB. So I have done a talk at one of the last MongoDB events where we have built a digital twin on MongoDB. So the great thing here is Kafka complements other technologies. It's not always competitive to each other. And so this is the high-level overall use case described in a few minutes. And I even can show you here on GitHub if you want to take a look at that, because I also have a video recording which shows this in 10 or 15 minutes in more detail. So you can check out my GitHub. And
Yeah,
here,
for sure. We'll link that in the show notes for anybody that
we really have implemented exactly this use case I just described. It's running in our case on GCP on Kubernetes, but this is just because it was simple for us to build. But this is in the end what we did on in this implementation.
Well, I think it's really interesting how you talk about how this simplifies the architecture very much when you compare it to like a model serving platform. I'm wondering about how you take into account these important factors such as reproducibility when you're looking at stuff like this.
Yep. I mean, reproducibility, I mean, the great thing about that, that's built into Kafka by nature, right? So in Kafka, you can store it. Everything is event-based and stored in Kafka in a log. You cannot change it when it's in there. You can just append new events. And therefore, you always have this kind of trace of events, which cannot be changed anymore with timestamp and so on. And so you can also reproduce it or check if something works. And for example, also, if you, for example, want to try different analytic models with different tools on that, you can be sure if you consume the same events with different tools or frameworks, you get always exactly the same input data and the same data quality. And with this, you can make sure that this is not the problem. And then you can, for example, consume it with TensorFlow, but also with an AutoML tool like Data Robot. And then you can compare the different technologies to each other and find out which one works better for you. So that's one of these great things which is built into Kafka because the log is event-based. And this is the huge advantage of this architecture. And the funny thing here is Kafka Connect, which is our integration layer, one of the first connectors we had was for S3, for the object store in AWS. And this is also one of our mostly used connector in our fully managed cloud service. And the funny thing was people ingested it into S3. One of the reasons was to build a data lake and put Spark on top of that. But then, and this was already 2 or 3 years ago, more and more of these customers came to us. They don't need just a S3 sink, but they also want to have an S3 source so that they can play data back from S3 into Kafka. And in the beginning, we asked them, why are you doing this? What's the use cases? And the use cases were exactly this, so that you can also play the events back, that you have them in the log, so that they can use them for these use cases. And so around 2 years ago, we have implemented the S3 source for exactly this use case, so that you can build your pipeline in both directions out of the box. And this is exactly where tiered storage comes into play, because now for many use cases, you can avoid this pipeline because it's built into the application of just the Kafka infrastructure.
Oh, nice. Yeah, that's super interesting to think about and just wrap your head around.
Yeah.
I think we have a question in the chat from Mark. He's asking about if the car model with the independent Kafka, so let me just see. Does the car model with the independent Kafka allow for changing scoring parameters along the way? Say if you need for post-sales ops change.
Mm-hmm. Yes, so this is, by the way, I also have another talk here. This is also which I can show you here if you Google for...
We're getting like 3 talks in one right now,
yeah.
aren't we?
I did a talk about this at a former Kafka summit where I just discussed the trade-offs of model deployment in a model server versus deploying it directly in the Kafka application. And if you Google for that, you can also find the slides and video, and you can take a look at that in more detail. But on a high level, there are some trade-offs, right? So let me walk you through this. in the end, here it's in one slide are the trade-offs by embedding the model directly into the Kafka application. The model server has, as on the left side, has many things out of the box, like versioning, like out of the box changing parameters and so on. This is not here out of the box in the Kafka application because it's not a model server, right? But as I said here on the right side, for some use cases like connected cars, for the latency, and if you're offline in a tunnel in a car, also what many people underestimate is that if you have different systems connected to each other, like a model server and connected with RPC, then what happens in case of failure, or what happens in use cases where you have a business transaction with exactly one semantics? That's simply the things you need to think about. And having said this, we have customers really which more or less implemented some of the characteristics of a model server relatively easily in a Kafka application. And like your example for changing the configuration of a model, of a hyperparameter or of something else, there's different options how you implement that. And of course, also it depends on what technology you use. If it's more something like deep learning for J, which is a Java application anyway, or if you just want to load a new version of your model, there is different kind of how people do this. The most interesting one I would say is we have seen customers which really send these updates also via a Kafka topic. So this means that you start your new application, it loads the current model and uses it for real-time predictions. But then when in the back end the data science team finds out we should change our model or some of it weights, then we just send the new metadata, the new weights via a Kafka topic to this application. And then without any downtime, this Kafka application internally changes these weights on configuration and does the new predictions. So this is a great option. In the real world, especially when you come more into regulatory environments, this is harder to do because you always have to prove what you do. And then something like A/B testing is often used so that you can still prove, hey, here we use the old model and here we're using the new model. And this, for example, is great with Kubernetes and pods. You just add a new pod and you do some A/B testing with a service mesh or these tools. There's plenty of different architectures and options how to do that. But it's definitely possible and not that hard.
Yeah, one thing I love about your blog posts is you tend to give many of these architectures that you're speaking of. You give, it's not just like a blog post and here's the one different kind of architecture. You give various different ways and you proceed to break down each one of those architectures. So that's something that I really enjoy about your writing. What I wanted to talk about now is this whole idea of the real-time monitoring and analytics that you spoke of. And so how does that work? I love talking about monitoring, and I think that this is something that it's top of mind for a lot of people. Can you go into that more?
Absolutely. I mean, maybe start from the beginning when I started my talks here, right? When we talk about this monitoring of analytics and so on, what I see in the real world, especially at bigger companies, which are not just a tech startup or so, these companies often have a lot of great data scientists which build models because that's often straightforward. You get a big CSV file and you use Python and TensorFlow in your Jupyter notebook, but then they struggle in deploying that to production. And this is not just about the scoring, which we just talked about, but it's also about monitoring the whole infrastructure, right? And so the funny thing then is, however, if you are using Kafka already for data ingestion anyway, for bigger data sets, because there you are forced to use Kafka because you cannot do it with a small messaging solution or a batch process, then if you get into this, then it's pretty straightforward then using also the same architecture for monitoring all of that, because that's then just a few new Kafka topics where you send new information in. And therefore, this is really pretty straightforward. So you can also use different components of the Kafka ecosystem for that. But in the end, we have seen many people starting just using Kafka for data ingestion into a data lake. But then when they use it more and more, then one of the easiest things is to also using Kafka for monitoring. And then it depends of what exactly you want to monitor or want to do. So Kafka here is also, again, not the silver bullet. You cannot use it for every problem. But for example, it's pretty straightforward if you have this Kafka infrastructure that you then simply use yet another time series database where you ingest these events which you want to monitor. And in a simple case on Kubernetes, people use Prometheus and a Grafana on top of that, right? Or you use, for example, a real time series database like Timescale DB or InfluxDB. That then depends again on the use case. But the great thing is here you're flexible, because as you're using Kafka as your infrastructure, you can just add another consumer to that. And that's what makes Kafka so different. In Kafka, the performance doesn't get worse just because you add more consumers to that. At least on a high level, that's this, right? So because they are so decoupled, and because the producers just produce and store it in the log, the producers don't care if more consumers consume it later. And so if you want to build monitoring, in the end, it's just one more consumer and one application on top of that. And that's it on a high level, of course, right? And then in deep dive, you have to decide between, is it more like a technical monitoring about uptime and latency, or is it really more about the business metrics like the model accuracy and so on? But that's then a detail which, in the end, you can decide which technology you use for that monitoring, but it's straightforward.
Kafka's like a gateway drug into itself. You start with just a little piece of it, and then you realize it does much more, and then you end up trying to utilize everything. So that's great,
funny,
man.
But that's how our customers start and what they are doing. So they start small with one use case, and then when this is running, and if you're in a bigger company, we see it all the time. If one business department is building their own use case, and then when this data is in Kafka, 5 other business units come in there and, hey, we want also to get part of the data. That's great, and this is really reality. So our customers, they start small often, but then they grow over time with many more and more projects around it.
Mm. And so do you feel that it is something that needs, like Kafka is related so much with like streaming, right? And when you're streaming data, do you feel that it has other use cases with just batch?
Yes and no. First of all, what people need to understand, so Kafka under the hood is typically using batch. This means if you build even a real-time application, for millions of messages, you don't process message by message, but both the producer and the consumer always take a batch of messages and ingest it or consume it or process it, right? Because otherwise it wouldn't perform that well. And this is the first thing which people should be aware of. Having said that, if you then want to do real batch processing in terms of like doing MapReduce or doing shuffling of a lot of data, this is where Kafka is not strong in. So this is really where one of the consumers of Kafka should be something like Spark, which was built exactly for this, for doing these kind of batch processes. And that's where Kafka does not shine, where typically people have one more materialized view with Spark and do the batch processing there.
So now I'd love to hear your ideas of some of the coolest ways you've seen people using Kafka. I mean, we talked about this use case with the car. Is there any other stuff that comes to mind where you're like, wow, that is something that surprised me?
Yes, and I could talk here now for an hour, right, about different use cases. But I also have the right slide here actually, because what amazes me most about Kafka is that it's used for so many different things. And this is really one of the key learnings. You can use it for everything because it decouples everything. It scales well. You can use it with any technology, no matter if it's Python or Java or even any commercial tool. Most of them have a Kafka connector, like middleware, like analytics tools. All of them integrate with Kafka because the market demand is there. And this is the most amazing thing. So for me, what's even more amazing than the things we talked about, machine learning and analytics and all these things, what's even more interesting for me is how many customers use it for integrating with legacy applications. So one of the biggest business cases for us is mainframe integration and offloading, because here easily you can save millions of dollars in a bank or insurance company. And this simply works very well even for that use cases, or integrating with industrial IoT scenarios. And so this is what's really the most amazing thing, that it's used for so many different use cases at really customers across the globe in any kind of industry.
Yeah, you can, it's like the Amazon of technology. You just use it for everything, don't you? And you get a little taste, and then you want to go more and more. So
the interesting thing is now, I worked for Confluent now for 3.5 years, or a long time, and Confluent was very small. And at that time, there was a little bit of Cloudera and Hortonworks, but they only use a small part of Kafka and only for ingest in their data lake. But Confluent is really the only vendor really focusing on the whole Kafka. But having said that, if you take a look today at the market, every big vendor at least tries to have some Kafka products. Not all of them do it well, that's another point. But all the big blue, the big red, all of them have several different Kafka offerings by themselves because the market demand is there. And when all the big software companies have some kind of Kafka products in place, then you really see that you are in the right market. And also, you might be surprised how many other end customers, like, I cannot talk about many of them because it's under the hood, but if you just check out the Kafka summits, right, how many solutions are using Kafka under the hood? This is ERP and MES systems, this is CRM systems, all of them use Kafka under the hood. It's LinkedIn, it's Uber. You can take a look in any industry and all of them speak at Kafka Summit because they use it under the hood for good reasons.
Yeah, I saw that slide that you skipped over earlier that was showing a few of the, like, I think it was Pinterest also is on there, and how much of the data they're using. That's it. There it is.
But the more important point about this slide here is the two things here at the top right. First of all, in the meantime, it's obvious that everybody's using Kafka, so not just the tech companies. But even more important, and that's maybe also good to discuss here, Kafka is not just used for big data sets. So that's what it was built for at LinkedIn 10 years ago, because there was no other solution for that. But today, and I talk to around 100 customers a year globally. So today, I would say that 70% of the projects I see with Kafka, it's not about big data. Because many companies don't have that big data like Netflix and LinkedIn. But what people use Kafka for, and that's why we come back to this slide, is they use it for building new business applications. And they use Kafka for transactional data, like customer orders, fraud detection. We have customers in banking for instant payment platforms, for global trading. This is the things, this is not terabytes of data. Maybe the logs under the hood, but the transactions is small data sets. It's much more important that you have zero downtime and zero data loss with exactly one semantics for this. So it's completely different use cases than just analytics, what Cloudera, for example, does, right? So our customers build the business transactional information systems around Kafka.
So we've got a question in the chat from P, who's asking, and he's prefacing this with, if it's too off topic, feel free to punt it. You don't have to answer because it might not come up, but he's saying, does explainability ever come into the conversation when you're talking to people?
Only indirectly, because that's really more a machine learning problem, right, which you have to answer. Part of that definitely is that especially in regulated markets like in healthcare and in insurance, this is a big topic. And here, therefore, it's not just about building the models, but also about where does the data come from. So it's also about data governance, about replayability, about being able to guarantee even after years that you can explain what happened. Like we see, one of the examples we see here in regulatory reporting at trading companies, which use Kafka under the hood for doing post-processing of trades. And these are the things where explainability is very important, sometimes just for the business rules, but also if you use analytic models. And this is where, again, Kafka shines, because the data is stored in the log in an only appended. And to go one step further, you can even make Kafka tamper-proof in a way that, so that's an additional framework or technology, but we have customers which thought about using a blockchain or so, and that's too complex. And then they still use Kafka in a tamper-proof way so that they can build these explainable use cases like for know your customer and other regulatory use cases, for example, also in the financial services environment.
This is fascinating. So aside from, I know you're a big advocate of Kafka. We can tell that you love it. You've been around hanging out at Confluent. You drank the Kool-Aid. I'm drinking the Kool-Aid too. I think Kafka is an absolutely incredible piece of technology. What other tools out there are interesting you at this moment?
So on the one side, what I really like is everything around AutoML, because it makes the use easier for other people. Like I'm a huge fan of these tools like DataRobot or also what the cloud services provide. So that's what I see. Not yet with Kafka that much, but on a higher level, people try to use that more and more. So that's what I really love. And on the other side, what I really like also is for any kind of IoT space where you really connect to millions of devices. Like that's what Lyft and Uber and all of these do, or what many other innovative use cases are. This is often not only Kafka, because Kafka is the event streaming platform, but then still you also build, for example, another gateway where you connect to the mobile devices. And Another technology trend which I really like here is the service mesh with Envoy and Istio and these technologies. But here I also have to say this is very early stage. It's still very complex and the tools are not mature yet. So this is what I think we will see more in 5 years or so in many more deployments. But so I think these are the technologies I really like, and they're partly also related to Kafka a little bit.
Awesome. Well, last question on that service mesh side of things. What is it that's got you interested in that, and why do you think it's still early days?
I mean, I also, that's also again funny. I have another talk about that topic. So, because
Of course you do.
yeah. So
I would expect no less from you, Kai.
yeah.
Let's see it.
I really like to talk about these technologies because I mean, I also see get these customer questions, right? Because I'm working on all these technologies. And there is a relation between service mesh and Kafka. It's really hard to explain this in a minute, but the point is that Kafka got the de facto standard for microservices, right? This is not always about big data, but more about business applications. And Kafka is used in the middle because it decouples the different microservices well, which is one of the main ideas of microservices. And in the past, people only used HTTP, which is on the one side, asynchronous communication, point to point. And also it's not scaling well and not for real-time applications, for high volume. And this is why more and more people use Kafka for microservices. And service mesh then is on top of microservices, no matter if with Kafka or without. And we have, for example, customers which use Envoy and Istio to configure a mutual TLS, so security configuration, evolve their total network on Kubernetes so that they don't have to configure it for each application by themselves and for Kafka different than for another application. And therefore, they simply use a sidecar with Envoy and deploy it for all their microservices. And this includes not just their Java applications with HTTP, but also their Kafka clients and even the Kafka server side with the brokers, because from a service mesh perspective, it doesn't matter if you attach a sidecar to a server broker or to a client application, and therefore it's really complementary. But having said that, I also have seen the pain at our customers simply that it's early stage, and so it's really hard to do that, especially in production if you're not a tech company with a lot of experts. So if you don't need it today, I wouldn't recommend it. That's simply my personal lesson learned. You're mute.
Thanks. I appreciate that. This has been awesome. I think that all of these slides and presentations that you've been showing us, can we send them to everyone?
That'd be great.
They're out, they're public, and
Yes.
so we will send you all a link to this. And if you're listening in the future, it's in the show notes below. So thank you, Kai. I appreciate this.
Yeah, it was great talking to you. It was really great discussions.
It's been an awesome ride and a little bit of a snafu at the beginning on my part, but I really want to say thank you to everybody that's listening still. This has been awesome, man. I really appreciate it, and I will talk to you later.